Okay, I'm recording now, and this is the lecture for Tuesday, September 15 for Math 1101, review of Chapter 4.3 and 4.4. This takes us through the vast majority of Chapter 4. So just wanted to go over a few things that we didn't have a chance to cover in detail last time as far as the details were, as far as the calculations were concerned. And so in this particular one, this first several slides will be review what we already did. The idea is to get to a goal of $10,000 in 5 years. And although we have covered this already, I did want to show a few of the numerical details that unfortunately have to be shown. So let's go ahead and show some of the details here. And it turns out that the numerator would work out to be 60. As I look at this part, 10,000 times 0.006. And yes, we are looking at, in this particular case, building the nest egg, retirement savings. So I usually just bundle the easy numbers together as well. But then what about that 1.006 to the 60th power? And then when you subtract 1, don't forget to subtract 1, instead of 1.43, you'll get 0.43. So let me just put down some detail. This one you could probably get by with a little less detail, but 4317, apologize for my handwriting, I'm writing at an angle, 88412, and you could probably get by with a little bit less than that, but you know, some people just go for all of the accuracy, and that way you don't have to worry about very much. $138.96 would be what you'd have to deposit every month, roughly $139, in order to have that kind of guarantee waiting for you when you're done. So let's continue, and we'll go down here and take a look at this calculation. And as we've talked about before, we had to have a needed deposit based on a goal of $500,000. So right now I'm just after the numerical details that you may have had a chance to look at since I had the last live class last Thursday. So first of all, as I look at the numerator, that the two numbers up on top, good idea to show this calculation, 3750. Even more important than that is 1.0075 to the 480th power. Now this is 40 years, so 480 months is a lot. But then you subtract 1, instead of 36 point something, you have 35 point something. That is a huge factor, as they call it. Some of those factors are much lower than that, but let me go ahead and put as many decimals as my calculator supplied to me. 0.10990204. I know this is just trivia, but without it, you can't get accurate answers, and they have to be somewhat accurate. So anyway, what we have here is a value of $106.81, so I'll just kind of point at it. But I did want to bring out, you know, stuff that I probably already said before. If you multiply this by 480, then you're down to only, you're put away $51,000, so I'll just round that to the nearest thousand. 51K is what you put in, and yet we're going to be withdrawing $500,000. How's that 10-to-1 ratio I mentioned? That's pretty good. Of course, you have to have an excellent interest rate for a very long period of time, 40 years, so good luck with that one. But if you can find something like that, that's a pretty sweet deal. Okay, let's go and find the numerical details for this next problem here. And now we're looking for a needed deposit with a particular goal. And it was the same problem. The only difference was we had a 6% rate, as we reviewed the last lecture. And so now the numerator turns into 2,500. So I sneak this in at the bottom. But 1.005 to the 480th power, it's a large factor compared to most, but it's only about a 10 instead of a 35. And we've already subtracted 1. Don't forget to subtract the 1. But I get 9.95745. A little bit more. 367. When you divide that into the 2,500, you'll find that, yes, you do get your $251 and change. And that means you had to put in more than double the amount in order to get the same amount back. And that's the power of the interest rate, especially over 40 years, which is a long time. Okay, so we had that formula, which we talked about before, so I'm not going to belabor that. I'm mostly here to redo the numerical calculations for you. This one's a little bit tougher, but not terrible. Once you practice these a few times, it's really not that bad. So the monthly annuity yield, as we discussed, depends on the nest egg, which we already have. Apparently this person's already got that money saved up. Wonderful, 800,000. And then you got your R, and you got the 1 plus R to the T. So let's show some of the details. I'm fond of bundling these two numbers together. They're pretty easy, really. So when you do that, you get 4,000. But 1.005 to the 240th, well, that number, according to my notes over here, is 3.31020. And a few more decimals, 4476. Okay, so that's required, all those decimals, because we have a very large amount of time, 20 years. My rule of thumb is around 10 years. 10 years or less, you can try to use less decimals. But I'm talking 5 or 6, not 2 or 1 or 3, because that tells me you're not really trying very hard, and you'll be graded accordingly. Certainly a big part of it is to know what formula to use and to start to use it, but then we're looking for detail and accuracy as much as you can get. And if it does slip a little bit and you do what I said and use at least 5 decimals for 10 years or less, then I will not worry about any slippage that may occur. But anyway, the same number shows up twice in a row. These numbers show up twice in a row with the major difference of a -1. So 3 minus 1 is 2. So 2.31, and all the rest is the same, 204,476. So that part at least is okay. Just copy the decimals twice. And then you calculate that out, and you do get your $5,731.45. That's what you could take home for those 20 years, probably in retirement. And we already mentioned that you'd be really taking out more than that. As you multiply that by 20 years, it's really about 1.4 million. We said that before. Okay, so now we have another calculation as we get towards the end of this review. Here we have 5% APR, compounded monthly. We'd like to find out what kind of nest egg we'll get when we have a yield of $4,000, or would we need in order to retire to only take out $4,000 per month, not $5,700, but $4,000. So it figures to be a little less because I think they left the other part the same. Well, let's show you how we could do this. We have the 4,000. And then 1, and this is a messy number here, so let's go ahead and just show you that by itself. I think I verbalized it before, but this is where it gets awkward, and this is where I seek to avoid these kind of calculations. If I have any say about it, you will not have to worry about this on a test. But as I say, I don't know. We have common tests or what. It's a group effort. Still waiting to hear. Well, anyway, that's going to be 0.004. Let's see, and then 1, and as many 6s as you can stand. I have 4 6s here, 4, 1, and now I have 6, 6, 6, 6, 7. That gives me all the decimals in the calculator. So that will have to be added to the 1. So then we have to, I'll show you a couple of other details. I don't have enough room on this slide, unfortunately, but let's see if I can slip in an extra step here. Got 1.004. This is where some students kind of lose emphasis here, which is sad. So that's the 240th power. We will have to subtract 1, but then remember the 4,000 goes around the whole thing, so I have to put extra parentheses. I like to use brackets instead of parentheses. The brackets tell me that we have a second layer. Otherwise it hides too easily, and I don't like it to hide. So down below we just have an R, and the R is just simply, as we just found out, the R was 0.004 and change, so I better write that down. 0.041666667, and that's just by itself. And then we get to multiply that by 1 plus that number to the 240th power, a number we just saw upstairs. But it will not cancel because the way it's arranged. Would have been nice if it did cancel, but no such luck. Let's raise the 240th power. And I don't see the need for extra parentheses here. You can put them in if you want, but they're not actually necessary. To supply a little bit more detail on this toughest problem, we have 4,000 times the result of the calculation upstairs. After you raise this thing to the 240th power, then subtract the 1. Instead of a 2, you'll get a 1.712. I'm sorry, this is kind of boring, but trying to get you some practice in case you had difficulty trying to work this on your own, which we hope that you've done. And there's some detail there. And then we'll have to divide that whole thing by a number that works out to be 0.004 times 2.712. So I'm afraid I'm running out of room. I can't really show you that extra step. Well, keep in mind, though, this number without the -1 down below where I'm trying to point, because I'm running out of room, is a 2.7126402, blah, 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 blah. But I'm going to bundle that already with a 0.004. I've just run out of room. I apologize. I didn't plan a blank slide in there. It's my fault. So that result does show up as 0.011302669. And then you'll get a number on top about 66850, 0.561, etc., 142. I'll just point, and then of course that works out to be around $606,000. And I apologize for my terrible handwriting. I'm writing at an awkward angle here. I wish we had a better system for doing this kind of thing, but that is supposed to be a 4 there. Sorry about that. But do the best you can, especially in problems like this, if you even see them. This would be a more difficult one. They didn't do you any favors with a difficult to handle R, especially when we are trying to do this stuff by hand. No, they rant and rave about how great Excel is, but then they forget to say, oh, it's not available on the test, but the students won't mind. Well, yeah, except, yeah, we'd like to understand how to do the test too. I can relate to that. I took a lot of tests in my career, including here at Cal State San Bernardino. Well, anyway, I think you'll find I'm the only one that's graduated from here on the entire staff as far as being full-time. But that's beside the point. Let's get to the part that we talked about last time. I kind of did a lot of it last time, but I didn't really finish it. Ran through this before so quickly. You have a bad Visa card, charges almost 23%. That is something I would dump like a hot potato, especially at today's interest rates. Maybe you can do better. Some people can't, though. Their credit worthiness isn't deemed sufficient enough. Then I would just say pay cash or pay off the card ASAP, like every month, I hope. Well, your previous statement had a balance of $500, you made a payment of $200, you bought $400 worth of clothes, and then find a new balance after 1 month. So let's see how that could go on the next slide. And we sort of previewed this before. One class went a little deeper than the other, but here I'm bundling the classes together. So here it does show you how it goes. You've got the previous balance, and this is what you would be subject to finance charge, hopefully as close to zero as possible. But you've got your previous balance, $500, you make your payment of $200, but then you also buy $400 worth of clothes. And so far we've got $700 ready to be charged, and they're gonna do it. They don't forget these things. So 22.8% is 0.228. That's not 0.0228, that's 0.228. It is divided by 12, so it's not really bad. I believe that was a 0.19. I'm going to quickly double check that, but that did actually go in evenly, but this one is not an extensive calculation, so we won't have to worry about that. That number did work out to be 0.19, around 2% per month, almost 2% per month. So they get that 2% on the $700, which, by the way, would be $14. Well, they're going to give you 70 cents back, so you only have to pay $13.30 for the privilege of using the credit card that month. And of course, they added on to the 700, means your new balance is $713.30. And here are some of the details on a chart, which sometimes they ask you to try to do. But remember, it's through the previous balance minus the payments plus the purchases. That seems to be obvious to most people. Payments buy down the balance, the purchases bring them up, and then that would equal the finance charge. Well, that would equal the subject to finance charge, so you have to get the percentage in there, and then that's what gets the finance charge rolling, and then of course you get your new balance based on that. So that's kind of a simpler problem, although a tad depressing in some cases. And so we're back to paying out money. 4.1 and 4.3, we're collecting the money from savings, etc., and then 4.2 and 4.4, not so much. Credit cards, well, they're definitely the ones that have the highest interest rates. They're supposed to be short-term, however, and that's the plan. So if we have a 24% credit card, wow, that is a lot. Well, the good news is that's 2% per month. I'll just go ahead and show you. 0.24 over 12 is exactly 0.02, 2%. So that's an easy one at least, so we don't have to worry about the calculator too much, but that's horrible interest rate. the minimum payment is 5% of the balance, and now we have a balance of $400, and we decide to stop charging. That's important. And we want to pay it off by making the minimum payment. Now, this is, I guess, meant to show you that this is not usually the way to go. This is for emergency use only in my eyes. I've been there, but hopefully, or thankfully, it wasn't a heck of a long time, but it was a while. So, you got to make the minimum payment, or they're going to have collection agencies at your door or doing other things to ruin your credit. But the minimum payment will not buy it down very fast. It can be a long time, like a mortgage. And if you want to turn your credit card into a mortgage, well, I wouldn't want to do that, especially with the high interest rates. At least with mortgages, their interest rates are lower, so that's one thing to keep in mind. Well, they'd like to find the new balance after we made our first minimum payment, and then find the minimum payment due for the next month. So let's go ahead and check it out. And the numbers here aren't terrible as far as calculations are concerned. So if you're only going to pay 5% of the balance, okay, good for you. You paid $20. That keeps them off your back, and they're actually kind of secretly happy because you're staying legal, and yet you're paying them maximum money, and they love that kind of thing. They know a certain number of people will be doing that, and that's what kind of keeps them in business. I hate to say it. I'm not a fan of the credit card companies, as you might have guessed. But anyway, amount subject to finance charges. We take the previous balance to $400, and we take off the $20 we paid. And then we did not make purchases. Now that's important. No purchases, because of course, if you keep making purchases, you'll never pay it off. But we're trying to simplify stuff. Somebody says, okay, I'm done with this card, no more purchases, and I'm just going to pay it off. I got to make minimum payments because of all the other things I've got going on. Okay, so the finance charge, we already kind of put that through on this line here, the third bullet point. I already did that on the prior slide, and we found it's 2% per month, so it's at least a simpler calculation. And this finance charge is $7.60. So you paid off $20, but they're going to get back around $8 rounded. So your total that you owe at that point is $387.60. Okay, well, 20 steps forward, 8 steps back, I guess you could say that. So you're paying it off, but it's slower than you might have thought. And just to finish it off, we can make the next minimum payment. So you could pause it right now and say, okay, this is the balance at the end of 1 month. But what about the next minimum payment? You have to be ready for it, and they'll let you know what it would be, of course. And 5% of what the balance is, use your calculator. Now it's going to be $19.38. If you compare it to back there, it has shrunk. And that's kind of the deceptive part about it. Well, I mean, it's nice in some ways that you're paying less, although it's very nearly the same in this case. But the thing is, they keep on stretching it out, and at some point, the book will say there is a minimum payment, whatever it may be, $10, $5, $20. When you get to a certain point on the balance, they'll just say, okay, pay up, you're done. Because otherwise it'd stretch out to pennies, and it may last 50 to 60 years, and you'd have to pay 2 cents 1 month, 1 cent the next month, and finally, but see, that's not good for anybody. No one cares for that. So they almost always have a minimum payment. We're ignoring that for this particular example. But a minimum balance is what I meant to say. I said it wrong. Minimum balance. Once you get to that level, maybe $220, you have to read the fine print of your credit card statement. Then they'll say that will be your balance due, period. And then no more interest, but it's just down to pennies. And it's just a waste of time for everybody. The book has more to say about that. And yes, of course, you should be reading your book, because this is only meant to sketch out the most important parts of the class, but it does not have everything, so you need to do that. While I have a bit of a pause here, yes, we did get WebAssign going, so everybody should have had the key by now. If you don't, please email me. I use the lists that people are enrolled with to send announcements out. I haven't worked on WebAssign very much, but we do have about 5 sections available, including the one from Chapter 1, the one from Chapter 3, and the first 3 from Chapter 4. Those should be due by the time of the midterm, which is the end of September. But keep working on that and do the best you can. I actually pulled it off their suggested problems. I did not alter them in any way. Maybe I'll take a closer look in some cases and change them around. But I appreciate any comments you may have as, oh, these are too easy, or these are too hard, or these are impossible, or any other feedback you have for me. I appreciate that. So send me emails or talk to me during the office hour, or talk to me after class if you'd like, as far as your comments on the homework, because I only skimmed through them. I was kind of running out of time that day, and I finally got WebAssign open. It was not easy, and got them for both classes. So You can work on the homework at any time. It is submitted electronically. Just assume that the first attempt counts, and that's, don't say, oh, I want to change my answer. Well, once you submitted it, it's in. And I don't know if they want you to do it all at once. I have not looked into that. I haven't taught this class in over a year, and they do have a different edition now, so I'm not sure how that goes. Anyway, sorry about that. Back to the plan here. Here's the minimum payment balance formula, and so what we have to do is after T minimum payments, that'll be equal to the initial balance, whatever you started with, such as whatever it was in the beginning. I can't remember what that was. And then we have 1 plus R, 1 minus M, the whole thing raised to the T power. Well, R is the monthly rate. We've seen that before, so that part is good. But M, that's something they have to tell us. It's the minimum monthly payment. So they'll tell us what that is. And it's going to be as a percent or as a proportion, a decimal of the balance. So a proportion is a better word to use. So anyway, let's take a look at an example and see how the formula might be used. Unfortunately, this APR is not as easy to do, but we can do it. 20% for the annual percentage rate. Minimum payment, only 4%, so they're stretching it out even further than 5%. We have a balance of $250 on the card. We stop charging, of course, and then pay off that balance by making the minimum payment each month and find the balance after 2 years of payments. Now remember, this is T minimum payments, so because these are always monthly, I don't know of anything that isn't, we're going to have to multiply 2 by 12 to get to 24 payments. In other words, T will be 24. And just to preview what's up on deck here, we've got R equal to APR 0.20 divided by 12. Well, that's 10 over 6, 5 over 3. That's 0.01666667. I'll just put down 6 or 7 decimal places. Let's look at the next slide and see what they have in store. Okay, let's see. I've got to make sure I get to the right slide. There we are. Okay, so there we are. 0.20, well, 0.2 is all they really needed. And as I punch that on the calculator and just check my work from the last slide, that is, of course, 0.016667. I'm going to stop at 6 decimal places and cross my fingers that hopefully that's enough. After all, we only have 24 months here. It's not like a 480-month deal. So if you hate long decimals, I don't care for them much myself, but I do like accuracy as well, though. So we have the minimum payment, 4%. 0.04 is what M would be. The initial balance is $250, so they've given us pretty much everything. So let's go ahead and take a look at the formula. The balance after T minimum payments, and we're going to be needing 24 minimum payments for the 2-year period. Initial balance $250. Then we have 1 plus R. They decided to put the fraction down. I wish they wouldn't do that. I would call that 1.016667. As many sixes as you wish. That will have to be multiplied, though, by 1 minus 0.04. That is 0.96, as I kind of write between the lines here. We actually have to find out what that number is first. Let me put brackets around it like they did, and I have to raise that whole thing to the 24th. Let me see if I can squeeze that in over here. The 250 hasn't gone anywhere, but the numbers that we have had in the brackets, 1.016667 times 0.96, we should find out what that number is. So as I check some notes I just wrote up an hour or so ago, that number happens to be basically 0.976. So I'm going to go ahead and write that in right here, 0.976, and I got some zeros after that, so that should be good enough. So you raise that to the 24th power. That number happens to be, as I put an extra step in, never hurts, about 0.55825. 0.55825. And when you multiply by 250, you actually get $139.56. I'm going to consider that to be basically a win. Now, bankers might have a heart attack about that one, but I'm okay with it. It's off by a penny. You did a good job with 5 or 6 decimals, and especially when I see your work. And by the way, to make sure I put those zeros in, there's your 5 decimals on the 976. Anyway, it's close, and that would be acceptable for full credit, in my opinion. Now, I don't know what WebAssign will do. I haven't checked it out that thoroughly with the new edition and all. I'm going to be doing that sometime in the next few days, and I'll let you know if I see anything to be aware of. Okay, so in this particular example, we have a balance of $10,000 on a Visa card with an APR of 24%, which is 2% per month. The card requires a minimum payment of 5% of the balance. You stop charging and begin making only the minimum payment until your balance is below $100. Find a formula that gives your balance after T monthly payments. Now, we've got 4 different segments to this problem, so I guess what I'm going to do is just take them one at a time and keep zooming back here. So let's use the formula. I just put in certain numbers into the formula. Get it set up is what they're asking you to do. I think it's a smart idea to do that. They gave us M. That was pretty easy. R was actually pretty easy as well. We already had done something like that before, and we found the initial the balance. With the formula, which you should get from your note sheet, which I imagine we will have. I haven't heard anything to contradict it. We have, of course, initial balance. Then you have 1 plus R, 1 minus M. So the R adds to your total. That's the interest rate, and the M takes away from the total minimum payment. Notice if R equaled M, you'd never get anywhere. If R was the same as M, you would just be spinning your wheels and have exactly the same $10,000 balance in forever and ever and ever, and that would not be a good idea. Unless you just, don't mind having $10,000 balance in an account like that. Well, 10,000 times 0.98 times 0.95, that whole thing is raised to the T power. Well, T here is 60, so that's getting to be a kind of a high number. I should close up that parentheses as well. And then you go ahead and crank that out, and you actually do get 0.969. That was exact. And it's to the 60th, so I almost wiped out the 60. Sorry about that. That's what that is there, so I filled in just a little bit of work for you. And the balance after 60 months, 5 years, you still owe over $1,500. There it is, $1,511.56. I checked this, and that's what you should get to the nearest penny. So that's kind of disheartening. I mean, you paid off $8,500 of it, but you still have $1,500 to go, and it's been 5 years without even charging anything to the card. Wow, that's kind of not very good. Okay, so as I slide this back, and let's see, I can't seem to get the arrows to work. I'm going to go back to problem number 2. Find your balance after 5 years of payments. So as I try to slide this up, let's see, go to part 2. Yeah, so we did part 2. I apologize. Yes, so we did 60 months, and that now gives us the formula. So for part 1, it was just the setup. And I suppose here's the setup here, and it's getting ready for a T to come in. And there have been homework problems that just stop there. So that's an awkward place to stop, I know, because it's like we're right in the middle of it. But that would give us a formula in terms of T. And then you can put in whatever T's you want. They suggest 60, so we're actually done with the second part of the problem. Let me go back and read the third part. Okay, let's see if I can try it the other way. Okay, well, let's see. I can't seem to go back. Okay, there we go. Part 3. Determine how long it will take to get your balance under $100. Now, this is where it gets a little bit tougher because we do have to use logarithms. We had logarithms briefly before with the doubling time. This is the last time, as far as I know. I'm pretty sure we're not going to see logs anymore, but let's just take a look at how long it would take to get our balance under $100. Okay, so here it is in part 3 of this example. How long does it take? Well, the idea is to use this 10,000 times 0.969 to the T power, and T is a variable, but we have to get it down to 100, not 1,500, but 100. It isn't quite 0, but it's getting close. Maybe that's the minimum payment or something, and then you're done. I don't know. It's possible. Well, the idea is to solve for T, and they have a slightly different way of doing it than I do. So you can take a look at their method, which is also found in the book, and also look at my method, which is basically use of the logs. And we understand that you've all had logs. Intermediate algebra did talk about them. So what we're going to do is try to solve for T. So just divide the 10,000 out. That's easy to get started. So 100 over 10,000 is just 0.01, 1/100th. That's just set equal to 0.969 to the T. Now they go through this argument about a equals b to the t is the same thing as t of log of a over log of b, and on and on. But I think what I'm going to do is show you how you may have seen it before taking logs. I will simply take logs of both sides, and I'll do log because that seems to be a little bit more popular. Log of 0.01 is equal to log of 0.969 to the t. Okay, well, as it turns out, with the law of logarithms, you can move that t in front and just say it's equal to t times log of 0.969. Now, if you want to solve for, as I write the left side there, we'd like to solve for t. I'll keep that bundled together. These are constant numbers that we are revolving around the t here. So I'm going to divide by that number there and get t equals, just as exactly as they say, log of 0.01 over log of 0.969. Do not need those extra zeros, but that's what I did. Just divide both sides by the log of 0.969. If you haven't done this in a while, it may look a little foreign to you, but come up with a way to do it, because this is certainly a viable question. And this is where our experience with logarithms certainly ends. Well, when you crank this out, and of course you have to type the number in and hit log, type the number in and hit log. You may have to write some numbers down, and I would suggest writing several decimals, at least 6 decimals, if you want to be accurate. And that works out to be 146.2 payments. And of course that's in terms of months. But the thing is, at 146.2, it's exactly 100. They did want it to be under 100. They didn't say around 100, they said under 100. So I actually have to go a little bit further. A few more days will bring it below 100, like $99 or something. So now we're looking at kind of rounding up, special roundup situations. These things happen in math sometimes. And that's 147 monthly payments. You know you're going to be below 100 at that point. At 146, you're slightly above 100. Well, when you put this in terms of months and years that most people want to do, what you really have is 12 years, 3 months. Now, you don't have to answer it this way unless the problem tells you to, but a lot of people just want to see that because it gives them more perspective of how many years it would be. And that's a long time. That's sounding almost like a mortgage, 15-year mortgage. And yeah, so the minimum payment is just not your friend. If you happen to have a credit card that's like 8%, and you have lots of other bills that have higher interest rates, that would be an exception, but that is so rare. That is so rare. So I just don't think that would happen very often. Now we have to go back and see what problem number 4 asked us about. So let's see. 4 says, instead of the minimum payment, you want to make a fixed monthly payment. This is just a review of before. So we have a fixed monthly payment, so your debt is clear in 2 years. Well, that's more like it. That's more like it. So that's good news. You'll be done in 2 years, not 12 years. So how much do you pay per month? And this is actually a flashback to something we've already done. So let's take a look at what happens. And oh, by the way, I should give equal time. The book does this, so let me pause for just a second as I finish up part 3. Determine how long it takes to get the balance down to 100. If you want to do trial and error, good luck. It's going to take you a while. If you really hate logarithms, then you've got some real number crunching to do. You could just plug in the numbers and see what happens. For example, you make a wild guess of 120, which isn't that bad a guess, it just isn't accurate. All you have to do is put the variable in there, and you get $228. But that's not 100. It's way bigger than 100, so you have to try another one. Say 140. That's another possible guess, and I cranked that one out. Got $121.71, and that's, of course, much closer. Now that we already know the answer, you kind of cherry pick it, put some dollar signs there, and you try 150. The thing is, you have to try at least 6, 7, 8, 9 values in order for it to show up as being something we'd accept as being accurate. So I've seen a couple people do this in the time I've taught this class. But people either do it with logs, maybe even using their version of logs, but or they just don't do it at all, because a lot of people will only try 2 or 3 of these and they're not very close and they just give up. So this is not the method I'd recommend, but if you don't mind crunching numbers and really hate logarithms, maybe you're one of the few people that would like this method. But I thought it was worth at least mentioning briefly. Back to part 4. Part 4, kind of a review of what we've already done, because now we're not using the minimum payment anymore. We just want to see what it would take to pay it off in 2 years. So in other words, this one in 2 years, 24 months, of course. So the amount borrowed was $10,000. We're lucky to have an easy interest rate, although it's a horrible interest rate. At least it's easy to calculate. Okay, so 24% over 12 is your 2% per month. 24 months, of course, and that's in terms of months. And now we have the formula that we've used before from a prior section, 4.2. The monthly payment will simply be the amount borrowed, $10,000, times the monthly interest rate, 2%, and 1 plus R is 1.02, plain and simple, raised to the 24th power. And then we take that same number, exactly the same, and subtract 1. Those do not cancel. I've seen a few people cancel those. That does not work. Let me provide you just a little bit more detail. As I bundle these two numbers together, 0.02 times 10,000 is 200. But 1.02 to the 24th power, and this one, notice I'm only going to use about 5 decimal places. I'm going to try to take it easy. It's been a long week, and it's late Friday as I do this. 1.608 and 44. And we'd have to take that same number and subtract 1. So 1 minus 1 is 0. For emphasis, I'll put the 0 down, 0.60844. So I divided that out, and I actually got it right. It was within the same range of values. There was no round off error at all. So this is one of those times. 5 decimal places did it just fine. There was that example back there where we had, was it the nest egg or something? And I put down 10 decimal places every step of the way, and I was still off by 5 cents. I don't know if you recall that, but that can be very frustrating. So anyway, you can do the best job you possibly can and still be off by just a small amount. So basically, I'm looking for the work you show me. The more steps, the better. Don't cut too many corners, please. It's almost never I see somebody gives me too many steps. I'm very impressed when I see that, but it just doesn't happen all that much. So that's something I don't usually expect to have. Oh yeah, I did have a blank slide. Turns out I could have used that earlier, but live and learn as far as these presentations are concerned. So anyway, that seems to pretty much finish off most of Chapter 4. We still have to get into the Excel stuff. I've got questions out because right now I can't even find my online book. I'm not sure where it went, but I don't seem to have it, so I'm looking for it. If anybody has any words of wisdom, let me know, but I've sent some emails out and nobody's responded yet. So once I get it, then I can get into the Excel material, but so far I'm kind of locked out. All I have is the loose leaf copy from the 2nd edition because they forgot to give it to me in my 3rd edition, at least the hardbound version of it, which that wasn't what I asked for, but hey, as long as I get it one way or the other so I can show it to you on the slides, whether it's live or recorded. So that will take care of the Tuesday lecture, and the next Thursday we'll be live, looking at my calendar. This was for Tuesday the 15th, and we'll be back live on Tuesday the 17th, both the classes, of course, and we'll continue with Excel, and almost certain that the test will go through the very beginnings of Chapter 1 and 3, and then most of Chapter 4, if not all of Chapter 4. But we're waiting to hear what the plan will be, and that's my tentative plan, to try to get through those sections. So if you have any questions, please drop in on the office hours. I've got the morning session around 10:15 and the afternoon at 2 o'clock. And of course, email is always a good way to get to me too. So class isn't going super fast, but there is a lot of detail in Chapter 4. Sorry about that. Okay, so that'll be it for today, and we'll talk to you soon.